All right, we're starting with number 7. This is part 2 of the assignment video. And number 7 says sketch graphs. Y equals negative 4x. Y equals negative x cubed in one coordinate plane. Explain why the area bounded between the curves cannot be written as a single integral using negative 2 and 2 as limits of integration. Use symmetry to write a single integral for that area. But it doesn't say to but it doesn't say to actually find the area. So here we go. So step 1 is, can you sketch this? We'll see. So to be helpful to sketch this would actually be know where the two intersect. So I'm going to take negative 4x, make it equal to negative x cubed, and then I'm going to solve it. So I'm going to solve it by adding x cubed to the left side, make it equal to 0 and factor. So if I factor this, it's a difference of squares. So the x coordinates where they intersect are at 0, 2, and negative 2. For each one, I need to find the y coordinate. Now, I can go to either one to get the right answer. So if I use the line, then 0, 0, 2, negative 4 times 2. 2 gives me negative 8. And negative 2 times negative 4 is positive 8. So those are the points I'm going to use. 2, negative 8, negative 2, 8, and 0, 0. So I first made them equal to each other, found where they intersect. So now I have some points to work with in graph. So if I go to 2 and negative 8, 1, 2, 3, 4, 5, 6, 7, 8, there it is. If I go to negative 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, there it is. And then if I understand that 0, 0, I have that as well. So first, that makes a line. So those 3 points together make a line, but it also makes a curve for a cube function. So a cube function curves down to the right and curves up to the left because it is negative. And then I have 2 areas I'm going to shade in. And so for these 2 areas that are going to shade in, the next question, part B, is why can I not use one integral to find the area of the shaded part? And that's because to find the area of a shaded part, we need to go top, subtract bottom. But what happens if in one area, the line is on top, and then in the other area, the cube is on top? It takes turns, right? So you can't write as one. So you can't write as one logarithm because in one interval, y equals negative 4x is on top, and in the other interval, y equals negative x cubed is on top. So if you're going to find the area, it can't alternate. So whatever one is on top has to be on top for the whole time. So in one interval, the line is on top, and then in the other interval, the cube function is on top. And because of that, you'd have to write it as 2. Now, what we also notice here, because it's a cube root or a cube function, there's symmetry with the origin. So the area here is equal to the area there. So we have 2 areas that are equal. So I can just write this as 1 and then double it. So you can choose which one you want to do. So let's say I go from 0 to 2. So which one's on top and which one's underneath? So if I go from 0 to 2, negative x cubed is on top, and then the line is underneath it. So there's 2 ways you could set this up. So if I double this and go from 0 to 2, you could write it with, so from 0 to 2, the cube would be on top, and then the line would be underneath. You could also go from negative 2 to 0 and double it, and then you'd have to switch it because on the left side, the line is on top, and the cube is on the bottom. All right. Next question. All right, no calculator. That's no fun. And it says, find the average value of each function on the given interval. So f at x equals x cubed, and that's from 0 to 2. I want to find the average y value, or the average value, in that interval. So there's a little formula to set up for average value. So to find the average value, you integrate the function over the interval. So we integrate from 0 to 2, and then you divide by the difference of the limits. So then you take the upper, subtract the lower, and that's it. So that's the setup of it. So to find the average value, you integrate the function over the interval, and then divide by the difference of the limits. Now, if I'm going to do this, I have to, first of all, 2 take away 0, that's simple. The numerator, the antiderivative of x cubed would be x to the 4th divided by 4. And again, I'm integrating from 0 to 2. And then simply you plug in the upper limit. You don't have to simplify. Subtract the lower limit. And that's a great answer. So that is the average value of x cubed between 0 and 2. If I would simplify it, just for fun, this would be 16 divided by 4. And then 4 take away 0, and then divided by 2. The average y value between 0 and 2 is 2. That's the average value of the function in that interval. All right, number 9. Again, I'm finding the average value in number 9. So let's see, what's the function in number 9? So let me look here. So the function's given as 1 over t subtract 1 squared, and the interval is from 2 to 5. It must be continuous again in that interval, so if there's a discontinuity in the middle, we wouldn't be able to do it. So it is not continuous at positive 1, but 2 to 5, it's continuous. So what's the setup again? And so the setup is we're integrating over the interval, and we're integrating this. Now to make life easier, I'm going to write this to the exponent negative 2, and then I divide by the difference of the bounds. Just like that. The antiderivative here, you add 1 to the exponent and divide, and that's all divided by 3. Notice the hook here. There is no hook, so positive 1, so it's perfectly set up to add 1 and divide, and then divided by 3. And it's a definite integral, so we're substituting in from 2 to 5. So now the next step is to substitute in. So first I substitute in 5, and then I substitute in 2. And there's your setup. Negative 1 divided by 3 ends up like dividing by, they combine together to make negative 3 when you do that. Again, you could simplify it, but I don't want to. That's the right setup and understanding of it. 10. In number 10, again, no calculator. We have a function. I want to find the average value of that. And then how do I find the average value from 1 to 4? So a simple formula that we use for average value, and that is we integrate over the interval, so that's 1 to 4, and we integrate that. Now I'm going to write this in a calculus-friendly way, and then divide by the difference of the bounds. So there it is. Next, the numerator, I'm going to integrate. So the antiderivative of 2y is y squared. Here, I have to add 1 to the exponent, so that's 3 over 2, and then divide or times the reciprocal, which is 2/3, and then I'm integrating from 1 to 4, and that's over 3. Make it simple, please. Plug 4 in first. That's 4 squared, subtract 2/3, 4 to the 3 halves, all divided by 3, subtract. Now what do you substitute in? Positive 1. And we have our answer. The upper bound, subtract the lower bound. Just practice copying it perfectly. And then just substitute in 4, substitute in 1, and it's done. All right, number 11. In number 11, it says to use my calculator. I hope I have one that's charged. I think I do. So it says use a calculator to find the average value. So we have f of t equals t squared subtract 1, square root of t plus 1. And that's on the interval from 0.4 to 3.2. That's super ugly. But you know what? Our calculator does not care. Here we go. So how would I type that into my calculator to find the average value? So here we go. Oh, have I not been even showing you my work, have I? Have I not been showing you my work going back and forth? I can't remember. Let me go back here as I talk through with it. I don't know if I've been showing you my work or not. Here's number 7. When I graphed it, and we integrated from 0 to 2, and the curve was above the line, and we made them equal to each other and solved it. That's not very good for me not to show my work. There it is. You can't write there. Maybe I can't remember if I showed my work or not. I'd have to go back in terms of what was happening. So that's the work we've done so far. You can press pause, of course, if you need to. I think I have. Now my brain's fried sometimes. All right, number 11 here. Okay, this is what we're going to show in our calculator, is the setup. Let's just set it up. So the average value is integrating from 0.4 to 3.2. And I'm going to integrate t squared subtract 1 over the square root of t plus 1 dt. And then I'm going to subtract the bounds. So that's what it's going to look like. So can you put that in your calculator? So let's see. Okay, so step 1, I'm going to go control divide to get a divide sign. And then I'm going to integrate on top. So menu, calculus, integration. And then the bounds go for 0.4 up to 3.2. And then I'm going to do another control divide to do another fraction. So that's t squared. Subtract 1. In the denominator, the square root of t. Move the cursor, plus 1. And that's dt. So there's the setup for the numerator. In the denominator, it's 3.2. Take away 0.4. Control enter, and then round to 3 decimal places. So I get 1.105. So the average value of that function from 0.4 to 3.2 is that, 1.105. Number 12. Use a calculator again. Find the average value. So I'm going to integrate from negative 2 to 1, 0.5 to the x dx, and then 1 subtract negative 2. Subtract the bounds. So this is what it looks like. Oops, I didn't mean to do that. I hit podcast. Weird. Let me just close that. I don't know why this is on there. Okay. So can you put that in your calculator? Let's do it together again. So I'll start with a fraction. So control divide. And then I'm going to go menu and calculus and integrate. And I'm going from negative 2 to positive 1. And it's 0.5 to the exponent x dx. And then in the denominator is 1 subtract negative 2. And there's your answer. So 1.683. So that's the average value of that function from negative 2 to 1. Number 13. Find the exact x value where the function in problem 8 equals its average value. So I have to go back to number 8. The answer to number 8 was, I lost it. The answer to number 8 was 2. So from 13, I need to go 2 equals x cubed. So let me show you again. So in number 8, the answer was 2. If you go back, make it equal to the function. Find the x value when this is true. So the average value of the function is 2. So to get x by itself, you just do the cube root. And so when x equals the cube root of 2, that's when the average function equals the value of the function. Number 14. Use a calculator to solve for c for the equation h at c equals that in problem 12. So in other words, for number 14, and I just did this one. So again, this is the setup. Once you find the average value, make it equal to 0.5x and find the x value where it happens. So that's what it would look like. Now, I'm actually going to take the full number when I use it in my calculator. So how do I solve that with my calculator? I'm going to help you here, okay? So I want to solve that. So I'm going to press Menu. I'm going to go to Algebra and Solve. And then I want to type it in. So it's 0.5 to the exponent x. Move the cursor, equals. And again, I want to use that whole number. So you see how I highlight it? Press Control C. And then come down here and then press Control V. And now the entire number's in there. And then go comma x. And now solve it. So where does it occur at what x value? And you have your answer, which is negative 0.751. Number 15. Next page. It says use a calculator to find the shaded area between 2 sine x and negative 3 cosine x from 0 to pi. Show an integral setup and express your answer to 3 or more decimals. Now, to do this, I actually have to set up 2 integrals. Now, why do I have to do that again? Because the top curve becomes the bottom curve after the point of intersection. So you can only use one integral if over the entire interval the same top and same bottom happens. But if they switch, and now the other curve is on top and the other one's below, then I have to set up 2 of them. So step 1 actually is to find that point of intersection. All right, I'm going to try to do this to the best of my abilities and show you. So if I want to solve it, I want to go to Menu. I want to go to Solve. Make sure it's in radians. See how it says RAD? I'm going to go to Solve. So Algebra, then Solve. And I'm going to type them in. So if I type in, it's 2 sine x equals, and on the other side would be negative 3 cosine x. Now the challenge with trigonometry is they're waves, and what happens with a wave is that there's multiple answers. So what I'm going to try to do, and I haven't done it that often, but I'm going to try. So I want to solve that, and I think I'm going to do it this way. So, let me do this. So if I do it this way, where I make them equal to each other, x, and I try to solve it, you're going to get an ugly answer. And so you get that looking answer because it keeps repeating over and over again when they intersect. So there's infinite number of times they intersect. So I just wanted in the interval between 0 and pi what it would be like. So I can actually put a domain restriction on this. And so I'm trying to figure out how I did that again. I did it once. So this is what I'm going to do. I'm going to go control. I'm going to put it in between. Oops. Let's come back here. So beside the equation, I'm going to try it just straight up. Beside the equation, I'm going to put the restriction that I only want the answer between 0 and pi. So between 0 and pi, I want the answer. So I'm going to see if I can make it. If it doesn't work, I'm going to try it differently. So between 0 and pi. So I want control equal sign. And then I'm going to go less than, and then x, control equal sign, less than again, and then pi. And I want to see if this works. I might have to do something different. So, it didn't like it. Okay. Let me try it this way. There it is. So, learn something. I'm trying to practice, be better with this calculator. I want you to notice what I did. So, I made the trig equal to each other. This is really important for trigonometry. That when you make them equal to each other, there's most of the time there's an infinite number of solutions. So I typed it in the way I normally do. Then I press control equals, and there's a vertical line, which means at, and then I put the restriction in. I only want the answer between 0 and pi, and then it only gave me one answer that I'm looking for. That is the point of intersection using your calculator. That's a big time skill. You should rewind and make sure you know how to do that. It's big. Okay, so again, I'm going to copy paste when I actually set it up. So now I have a number to actually set up for number 15. So let's go back again. So now I know what that x value is where they intersect. So now I need to know for on the left of that point of intersection, which one's above and which one's below. So I have to know my graphs. So one graph is positive 2 sine x. Sine always starts in the middle. Positive 2 means it rises. Negative 3 cosine, cosine starts at the top. But if it's negative, it starts at the bottom. So if you look at it, first 2 sine x is on top, and negative 3 cosine x is on the bottom, and then they switch. So just remind yourself of that from 0 to pi. So, what is the setup going to look like? Two of them. So one setup is going to go from 0 to the point of intersection that I just found, which is 2.1587, whatever. Again, I'm going to copy paste to make sure it's a really long number in my calculator so it's super accurate. And 2 sine x is on top, subtract negative 3 cosine x is on the bottom. So there's the first setup. Now the second setup, the second integral, goes from 2.1587989 and it goes to pi. That's the second one. And now it's switched. Now negative 3 cosine x and then 2 sine x. So that's the setup that we're going to put in our calculator, and then we'll write down the answer. So if you want to, you can press pause to know and then type it in with me when you press play, and then we'll do it together. So this is what it looks like on the calculator. So menu, calculus, integration. The bounds go from 0. Now, I need to copy paste that. So, here, let me see if I can just do the number. And then double click it. So there it is. So go over it with the cursor pad, double click, Control C, and then come back here and then paste it into the top, Control V. So now you have a great full number that you didn't shorten up too soon. And then you type in 2 sine x, move the cursor, subtract, parentheses, negative 3 cosine x, dx, plus menu, calculus, integrate. And now, again, I'm going to go Control V because it's already in the calculator, so I don't have to do it again. It goes to pi. There it is. So I can just put pi in. And then it switched, so now it's negative 3 cosine x. Move the cursor, subtract 2 sine x, dx. That's all of it. And then go Control Enter. Practice. Can you get that answer? 7.211. And there's your answer. So see if you can rewind and play and rewind until you can actually type that in your calculator, and you know you get the same answer as me. All right, Mr. G Math, over and out. I'm going to do a third video on this assignment. Yay. See you soon.